Welcome to AP Podcast 14.5C. This is our third example of titrations, and in this time, what we're going to do is we're going to take a weak base and titrate it with a strong acid. If you remember last time, it was a strong base titrating a strong acid, and so it's kind of the opposite. And so, much like last time, we're going to have an equilibrium, we're going to have a buffer, we're going to have just a strong acid, and so you're going to get a little bit of everything. It's kind of neat, but it's very similar to the last problem we did with the strong base and the weak acid. And therefore, I'm just going to kind of breeze through this quickly because you know how to do the calculations. So here we go. I've got this scenario right here, and I've got some ammonia. So imagine us having some ammonia, right? Oops. How about I write ammonia and not ammonium? There we go. So I've got some ammonia, and it's a base. We add it to water, right? And we get NH4 plus and some OH, right? So what we have here is when we are at 0 mils right there, then we know all we've got is this situation, this equilibrium. So this is a good old KB problem that we've done many times, right? We've got NH4 on top here times the OH. You guys have done enough of these where you're probably sick of seeing this over NH3, right? And that the KB equals 1.8 times 10 to the minus 5. And for those of you with headphones, I apologize about my dogs there. Somebody came by. Anyway, so when I solve for X, and remember that X in this situation is OH minus, I get something like, let's see, I got it written here somewhere. I get 9.5 times 10 to the minus 5th, and that gives me a pH of 10.96. So let's look at our curve now. So at 0 here, my pH is 10.96. And this is a curve that we haven't seen yet, right? We've seen all these curves down here going up like this. Well, remember, we're starting out with a weak base, so our pH is going to start high, all right? So let's see what they want us to do on the next one. Okay, at the next one, we are finding the halfway point. All right, the halfway point. What would that be, the halfway point? Well, let's see how many mils am I titrating here. It looks like I'm titrating 100 mils of this stuff, which is 100 times 0.05 would be 5 millimoles, right? And so I've got 0.1. So halfway would be, let's see, 25, I believe. All right, so 25 mils would get rid of half of that. Now, at that point, here, let me just erase a little bit here. At that point, when we've added 25 milliliters of stuff, 25 mils, right? Then I would have 2.5 millimoles, and again, I would have 2.5 millimoles. And then, of course, the important thing to remember, guys, is when we're going to put these into our equations, we've got to remember about the total volume. What would be the total volume? Well, I started with 100 up here, right? And I've added 25, so this would be 125. All right, I'm not going to go through it again because we've done these quite a few times. So let's just go quickly. When I use the Henderson-Hasselbalch equation, the pH at that point is 9.25. So let's go to our curve over here. And 25, let's see, that's 100 mils, so 25 is right around here, I would say. Well, I don't know. I'll put it right there. We would get 9.25. Okay, so right in there. I don't know if that's really halfway. That's probably not the best halfway drawing, but let's move on. All right, at the equivalence point. Well, at the equivalence point, we have used up all of this acid, right? And if you remember, that equivalence point is right along this line right here, right? Oops. Right there along that line, okay? So at the equivalence point, what I have is I have 0 moles of, let's see here, let me get a pen. At this point, I've got 0 moles of this, millimoles of base, of ammonia, but I've got 5 millimoles of ammonia, right? Now, What is ammonia going to do? Remember this. Now we've got this weak acid floating around. So what that's going to do is give us some NH3 plus some H plus, right? So now we've got a weak acid, and so we need a Ka for ammonium. Of course, we don't have a Ka, but we do have a Kb for this, right? And so the Ka will equal the Kw divided by the Kb, and we'll get a Ka. You guys know the routine. We've done it a number of times. Again, for speed-wise, when I do that, I get a pH of 5.36. Okay? So let's go over here to our curve. And so right here at the equivalence point, it's 5.36. Now again, notice it's not right at 7. Hopefully that makes sense to you. Why is it not at 7? Well, at 7 there's no concentration of acid or base that's greater, right? Well, in this situation, remember, when we're at the equivalence point, we have, right here, we have this acid. Okay, it is a weak acid, very weak acid, but we still have it. So that's why we get that situation. Okay, let's see what else do they want us to find. That's at beyond the equivalence point. And you can see right here I just said 60 mils, right? Well, what does that give you? That gives you 10 mils of HCl, right, that hasn't been neutralized. And so with 10 mils of 0.1 molar HCl, what do I get? I get 1 millimole of H plus. And of course, what's the total volume? Well, you're going, obviously, Mr. Richardson, it's 160 because you're good at this stuff by now, right? Excuse me. And so when you do that, you figure out the pH equals 2.21. All right? And so we go back to our curve, and here we are at 60 over here at, 160 at 2.21. All right? So again, I know this was fast right here, but we have done this. We've been working on these, and hopefully we don't need to just spend so much time on it. Again, we're using Henderson-Hasselbalch, but the important thing is all this chemistry that's involved, right? You've got to be aware of what's going on when you get to that equivalence point. You got to be aware of what happens when you are at 0 and you have just a weak base problem. So we've got the weak base. Then we get a buffer at the equivalence. Then we get, at the halfway point we get a buffer. At the equivalence point we get a weak acid. And then finally we get a strong acid. A little bit of everything. Kind of fun, kind of exciting. So we'll practice some of these problems. Hopefully this made some sense to you. I know it went fast, but I was going through a lot of steps that we are, or should be, pretty good at by now. See you next time.